Hello, my name is Chris Eberly and I'm an applications engineer at Plexum. I'd like to welcome you to the second part of our tutorial video on creating custom components using PLECS. This video follows an introductory video that highlights the creation of subsystems and configurable subsystems. In this video, we will cover the topic of providing full customization to a subsystem, including its own icon, block parameters, and probe signals. We will also discuss how to create new library components. We will start this video using the same models that we ended our previous video with. As a reminder, we have created a subsystem that contains a three-phase LCL filter. By masking our subsystem, we create a custom user interface for our filter subsystem that hides the underlying schematic, making it appear as an atomic component. To mask a subsystem, select the block, then use the keyboard shortcut Ctrl-M. The mask editor will then appear. This window consists of 4 tabbed panes. The first tab, named Icon, enables you to create icons that show descriptive text or labels, graphics, and images. The specific commands can be found by clicking the Help button or in the Plex user manual. The block icon for the LCL filter subsystem component to the right was drawn using commands in this fashion. There are 3 properties at the bottom of the icon pane that are also useful. The first setting can be used to hide the rectangular subsystem frame that encloses the block, which may be useful when drawing a custom icon. The second property will allow us to hide all of the subsystem terminal labels at once, like so. We can also decide when an icon is drawn if it rotates with the block. In the next tab, named Parameters, you define the parameters that will appear in the dialog box of the masked subsystem. Similar to when we open up a component such as an inductor and see a list of parameters, we can specify what the parameters are for this subsystem. Mask parameters are defined by a prompt, a variable name, and a type. The prompt provides information that helps the user identify the purpose of a parameter. For the inductor, the parameter prompts are inductance and initial current. The variable name specifies the variable that is used to store the parameter value. In this way, we can pass the same inductance value for all of the 3-phase inductors, and if we wanted to change this value, we therefore just have to do it in the block parameters window rather than for each component in the subsystem. There are 4 parameter type options. Parameters of type edit are shown as a text edit field. Parameters of type combo box offer a choice of predefined values. The possible values are defined in the combo box values field. Parameters of type checkbox can be set to true or false. Finally, parameters of type thermal allow the user to specify a thermal description. You can add or remove parameters or change their order by using the 4 buttons to the left of the prompt list. The mask initialization commands are evaluated in the mask workspace when a simulation is started. You can enter any valid MATLAB expression consisting of MATLAB functions, operators, and variables defined in the mask workspace. Let's add a mask parameter for the resistance that we will define as rFilter and allow the user to specify a value for using the edit type. In order for the resistance values defined in the block parameter window to be passed to the 3 resistors in the subsystem, we also need to provide the rFilter variable for each of their resistance parameters. Returning to the mask editor window, the probes pane allows you to define the probe signals that the masked subsystem will provide to the Plex probe component. In order to find a mask signal, you must first add a signal and name it, and then drag the desired component into the dialog window. Next, enable the desired component signals in the list on the right by using the checkboxes. For example, we may want to be able to probe the capacitor currents from outside of our subsystem. We will add a new signal and name it IC filter, then drag in the 3-phase meter from within the subsystem and select the measured current signal. Now if we drag the subsystem to a Plex probe, the 3 capacitor currents inside can be measured directly. The last tab is for documentation purposes and allows you to define the descriptive text that is displayed in the dialog box of the mask subsystem. Going back to our inductor example, the mask type corresponds to the text inductor at the top, and the mask description corresponds to the text ideal inductor. We will just name the mask type LCL filter and write the same for the mask description. We can now close the Subsystem Mask Editor window and show that clicking on the subsystem block will no longer show us the schematic underneath, but rather the block parameters dialog window where we can now specify the resistance value. In order to view the subsystem schematic, we have to select the subsystem block, then look under the mask using the keyboard shortcut Ctrl-U. Now that the subsystem mask has been created, we must choose Edit Mask from the subsystem menu or use the keyboard shortcut Ctrl-M to make any changes. To get an idea of what a more complete mask subsystem looks like, we will refer to the configurable LCL filter subsystem block that is in the second model file to see the drawing commands, the mask parameters, and the description. Whether we have created a very general or very specific custom component design, we can save it into our component library so that it becomes easily accessible and reusable, and even share it with our colleagues. Any PLECS model file can be used as a library component such that the blocks or subsystems contained within are added to the component library. To create a new library component, we copy the desired blocks into a blank model and save the file, and then need to set the links to this file in the PLECS preferences. Let's just place the subsystem we have created in a new model file and then save it to the desktop as filter.plex. To make a model file available as a library component, the directory and file need to be added to the search path and user libraries lists, respectively, which are found in the Libraries tab of the PLECS Preferences window. We will now go to this window and add the desktop directory to the search path list. Once that is done, we can select the .plex file containing the custom component and add this to the user libraries list with a custom description. Our LCL filter subsystem will then appear at the bottom of the component library in a new library tree with the same description name. To use an existing PLECS library component as a starting point for your own custom designs, you need to first break the link between the library reference and the library component. This is because when you copy a library component, either into a circuit schematic or another library component, PLECS automatically creates a reference component rather than a full copy. This means that you cannot make changes to it without first breaking the link to the library. As an example, you may want to use one of the PLECS pre-built 3-phase converters and add a custom filter to it as we have just shown. In order to break the link between a library component and its reference, select the reference component, then choose Break Library Link from the Subsystem submenu by right-clicking. After breaking the link to the library, the component is then independent from the library, such that changes to the copy no longer affect the library component itself. In the case of the IGBT converter, we can now modify it to add the passive elements, for example. This concludes our 2-part video tutorial on creating custom components using PLECS. All of this information and more specific details can be found in the PLECS documentation that is accessed from the Help menu. Thanks for watching.